Imagine stepping into a machine, pressing a button, and suddenly finding yourself in a different era. That's the allure of time travel. It's a concept that's fascinated us for generations. From science fiction novels to blockbuster movies, we've all at some point dreamt of voyaging through time, visiting the dinosaurs, witnessing historical events, or even getting a glimpse of the future. It's the ultimate journey, isn't it? Breaking free from the shackles of the present and venturing into the unknown realms of the past and future. This fascination isn't just limited to pop culture. Even in the scientific community, time travel has been a topic of intriguing debates, challenging our understanding of the laws of physics. But could we ever turn this fantasy into reality? Let's delve into the science, explore the theories, unravel the paradoxes, and see if we can get a step closer to cracking the time travel enigma. The concept of time travel isn't just science fiction, it also has roots in real scientific theory. Before we can even entertain the idea of time travel, we must first understand the fabric of our universe. And that's where Einstein's theory of relativity comes in. This groundbreaking theory, proposed over a century ago, revolutionized how we view the universe. But how does this relate to time travel, you might ask? Well, Einstein's theory of relativity posits that space and time are intertwined in a four-dimensional structure known as spacetime. Our everyday experiences allow us to perceive three dimensions of space: length, width, and height. But Einstein introduced us to a fourth dimension: time. Now, here's where things get really interesting. According to Einstein, the presence of mass or energy warps the space-time around it. This is somewhat like a bowling ball sitting on a trampoline, causing the surface to dip. In this analogy, the bowling ball represents a massive object like a planet or a star. And the trampoline is our space-time fabric. This warping of space-time affects how time flows. In regions of high gravitational force, time actually slows down compared to regions with less gravity. This phenomenon is known as time dilation. If you've watched the movie Interstellar, you've seen a dramatic portrayal of time dilation where an hour on a planet near a black hole equates to 7 years outside its gravitational pull. So, in theory, if we could create a spacecraft that could withstand the immense gravity of a black hole, we could potentially slow down time for those on board compared to the rest of the universe. This would be a one-way trip to the future. But before you get too excited, remember that we're currently nowhere near the technological capability to achieve such a feat. However, these concepts do provide a theoretical basis for time travel. So, according to these theories, time travel might not be as far-fetched as it seems. But if we could travel through time, we would inevitably face some paradoxes. Paradoxes are curious creatures, aren't they? They seem to challenge our understanding of reality, and time travel is fertile ground for these mind-bending conundrums. Let's consider the infamous grandfather paradox. Imagine, if you will, a time traveler who ventures back to a time before their grandfather met their grandmother. Now, suppose the time traveler interferes and prevents their grandparents from meeting. This action would result in the time traveler never being born. But if the time traveler was never born, then who traveled back in time to prevent the meeting? It's a loop that defies our understanding of cause and effect. Then there's the bootstrap paradox, another brain teaser. This paradox involves an object or piece of information that is sent back in time, creating a loop where it has no discernible origin. Think of it this way. If you received the blueprint for a time machine from your future self and then later sent it back to your past self, where did the original blueprint come from? It's a chicken and egg situation, isn't it? And let's not forget the predestination paradox, where attempting to prevent a certain event from happening in the past actually causes that event to occur. It's like trying to stop a raindrop from hitting the ground by putting your hand out, only to provide it with a platform to fall upon. These paradoxes present a fascinating quagmire, and they're not just intellectual exercises. They raise real questions about the nature of time and causality. Can the past, present, and future coexist? Can we change events in the past without affecting the future? Or is time a fixed line, unalterable and immutable? These paradoxes make the concept of time travel even more complex and intriguing. They challenge our perceptions, making us question our understanding of reality. So as we navigate the winding roads of time, we must be prepared to confront the paradoxical and perhaps even the impossible. But isn't that what makes the journey so captivating? So, how might we be able to travel through time? There are a few theories. Let's delve into the realm of the hypothetical, where we find ideas like wormholes and time machines. Wormholes, a concept deeply rooted in Einstein's theory of relativity, are essentially shortcuts through the fabric of space-time. Imagine folding a piece of paper in half. The shortest distance between 2 points is no longer a straight line on the surface, but a tunnel through the paper. That's a wormhole. Now, if we could somehow harness the power of a wormhole, it might be possible to travel vast distances in space and potentially time in an instant. But wormholes are extremely unstable. They need something called exotic matter to keep them open. Exotic matter is just as it sounds, outlandish, as it's something we've never observed, and it's supposed to possess negative energy density and a large negative pressure. So we're a long way off from packing our bags and hopping through a wormhole. Then there's the concept of a time machine. The most famous hypothetical time machine is perhaps the one proposed by physicist Kip Thorne and his colleagues. They proposed a wormhole time machine, where one end of the wormhole is accelerated to nearly the speed of light and then brought back to the point of origin. According to Einstein's relativity, time would pass slower for the accelerated end of the wormhole. So if you enter the stationary end, you would exit the other end in the past relative to the time you entered. But as fascinating as these ideas are, they remain purely theoretical. We're still in the early stages of understanding the mysteries of time and space. The advanced technology required to make time travel possible is far beyond our current capabilities. While these methods are purely theoretical at this point, they provide a fascinating glimpse into what might be possible. The possibility of time travel continues to captivate us as it opens up a world of endless potential and unfathomable consequences. It's fascinating, isn't it? So let's keep exploring, keep questioning, and maybe one day we'll unravel these mysteries of the universe. Time travel wouldn't just be a joyride. It could have serious implications for the timeline and causality. Imagine going back in time and altering a significant event. This could create a ripple effect, changing not only your personal history, but potentially the entire course of human history. What if you went back and prevented a war? Sounds like a noble endeavor, right? But consider this. Would the peace you've created be the same as the peace we know today? Could it lead to a different, possibly worse conflict? Or consider the butterfly effect, a concept from chaos theory. It suggests that small changes can have large, unpredictable consequences. A trivial action in the past could drastically change the present in ways we can't even begin to foresee. These potential consequences add another layer of complexity to the concept of time travel. It's not just about the journey, but also the profound effects that journey could have on our reality. Beyond the physical implications, time travel also raises important ethical questions. Imagine, if you will, the ability to alter the past. This capacity could be used to prevent wars, natural disasters, or personal tragedies. But who gets to decide what events should be changed? And what of the unintended consequences? For instance, changing a past event might erase some people from existence or fundamentally alter their lives in unforeseen ways. This introduces a moral dilemma. Do we have the right to interfere with the course of time, potentially disrupting countless lives? Moreover, time travel could be used for less altruistic purposes. It could be weaponized, exploited for personal gain, or used to rewrite history in a way that favors certain narratives. These ethical considerations remind us that time travel isn't just about science, but also about responsibility. It's a fascinating thought experiment that challenges us not only to understand the nature of time, but also to contemplate the moral dimensions of our actions. But is time travel really possible? Let's take a look at what current science has to say. Time travel, as we know it from fiction, is a dream that has yet to be realized. However, intriguing hints from the world of physics suggest that it might not be entirely out of reach. Theoretical physics, in particular, offers some tantalizing possibilities. Einstein's theory of general relativity, for instance, allows for the existence of wormholes, shortcuts through space-time that could, in theory, allow for time travel. However, creating and maintaining a stable wormhole poses significant challenges and Even if we could, there's no guarantee it would allow for any sort of meaningful time travel. Then there's the intriguing phenomenon of time dilation. According to special relativity, time runs slower the closer you are to a massive object, or the faster you're moving. In other words, if you were to travel at near light speed or hang out near a black hole, you could theoretically leap into the future. However, this is a one-way trip. There's no known mechanism for going back in time. Quantum mechanics, the other pillar of modern physics, also provides some interesting avenues for exploration. The quantum world is one of probabilities, where particles can exist in multiple states at once, and effects can seem to precede causes. Some interpretations of quantum mechanics even suggest the existence of parallel universes, which could perhaps offer a way around some of the paradoxes associated with time travel. However, all of these ideas remain firmly in the realm of theory. We have yet to find any solid evidence that time travel is possible, and many scientists are skeptical that it ever will be. But that doesn't mean we should stop exploring. The quest for time travel is, at its heart, a quest to better understand the nature of the universe. While we're still far from making time travel a reality, it's a fascinating field of study that continues to push the boundaries of our understanding. Time travel, a concept that has captured our imaginations for centuries, continues to challenge us in unexpected ways. From the theoretical foundations laid by great minds like Einstein to the paradox that boggle our minds, we've delved into the depths of this fascinating subject. We've explored hypothetical devices that could take us on temporal journeys and pondered the potential ripple effects of meddling with the past. We've also touched on the ethical dilemmas that such power would bring and the need for regulation to prevent misuse. The field of theoretical physics continues to push the boundaries, with ongoing research hinting at the possibility of real-world time manipulation. It's a complex and often contradictory topic filled with more questions than answers, but that's what makes it so intriguing, doesn't it? As we continue to explore the mysteries of time, who knows what fascinating discoveries await us in their future.